So we'll use direct sunlight, just like we have here. We'll use sunlight creates the wind. We'll take advantage of the wind. Sunlight creates rain. Rain comes down the mountains. We can trap the energy in running water. We can create hydroelectricity. Biofuels is the other secret weapon that we're going to harvest plants and burn them for energy, which is essentially what we do with firewood, but we're going to accelerate the process and we're going to streamline it and find plants that grow faster, et cetera, et cetera. Now, the important thing to remember here is that solar energy in its various forms is even more dilute than the fossil fuels. The fossil fuels are a highly concentrated form of solar energy. They're stored solar energy. The solar energy stored in the wind or in hydroelectricity is about 10 times as dilute, 10 times more dilute than the fossil fuels. And direct sunlight, the sunlight hitting us now here is although there's lots of it in the world, we say, well, we could power the whole economy 100 times over with the sunlight falling on the United States. But you've got to collect it first. You've got to gather it, and you have to collect it. And the problem with solar energy, it's very, very dilute. There's lots of it, but don't forget, the world is a pretty big place. It's easy to forget that sometimes in this age. But the world is a very big place, and it takes a lot of space, a lot of land to gather that energy. So when we start talking about the renewables, solar, wind, and so forth, the first thing to remember is they're more dilute than the fossil fuels. They're more highly dilute. Number two, it's going to take a lot of, the limiting resource is not the amount of sunshine reaching the earth. The limiting resource is going to be the amount of land it's required to gather that energy. And when you start talking, it's easy enough to say, oh, I'll put a solar collector on my roof, I'll put a windmill in my backyard, I won't have to buy electricity from the utility anymore. When you start talking about the actual amounts of space, of acreage involved, when you move up to a real life scale of these things, the amount of land is enormous. It's almost unthinkable. It's beyond anything we've ever experienced in industrial society. So, for example, the general estimate now, Scientific American had a cover story in January 2008. We're going to power the entire country with solar collectors. Let's put up solar collectors. Their calculation is that we would have to cover 60,000 miles, 60,000 square miles with solar collectors in order to produce enough electricity to run the country. That's about a quarter of Arizona. When you have a hydroelectric dam, you just think of the dam, it's easy to forget that what makes that work is the reservoir behind the dam. The two major dams we have, or the biggest dams we have, are the Hoover Dam in Nevada and the Glen Canyon Dam in Arizona. Both of them produce about 1,000 megawatts, which is the standard size of a standard power plant, coal or nuclear or gas power plant. Those dams both have reservoirs 250 square miles behind them. The reason we stopped building dams in the 1960s is because people got tired of seeing 250 square miles of scenic canyon area buried underwater. And most of the good dam sites are used anyway now. There really aren't any good dam sites left in the United States to build any more major dams. And in the whole world, China and Brazil are building giant dams now, but there really aren't that many sites left anyway. So the idea, in fact, what we're doing now is tearing down a lot of dams because people are saying, well, we want to let the fish run free and it's harming wildlife. So hydroelectricity really isn't much of an option right now, or it's an option we've used up pretty well. Biofuels is the other alternate renewable energy that's supposed to make a dent for us, we've already run up against the limitations of that very quickly. We're now burning 25% of the American corn crop into biofuels. We're transforming it into ethanol. 25% of the corn crop now goes into our gas tanks. And the result has been that we replace about 3% of our oil. Now, what we've done in the process is that we've created a world food crisis. That world food prices have been skyrocketing, and the UN has been screaming for about 3 years now that the problem, one of the major problems, is this biofuels effort. That when we turn 1/4 of our corn crop into fuel, we're putting tremendous pressure on food prices for the rest of the world. And it's even worse in the tropics. We've suddenly realized, my God, they're chopping down rainforests in Brazil and Indonesia in order to put up palm oil plantations and sell the palm oil to Europe and America as biodiesel. It's really close to being a world catastrophe. The idea that the affluent countries can use crops out of the third world, out of the underdeveloped world, in order to fuel their cars. It's literally starving people. So we've never really faced up to the land requirements that are created by these renewable energy strategies.